All right, so we're up to translations and lines in 2D. So we're going to start with translating a point. So if we consider a point A1, A2, so that just means that we've got a point out here. Its x coordinate is, so let's just pretend this is our point here. So we've got this point here, and it's got an x coordinate of A1 and then a y coordinate of A2. And it's on the plane. The position vector of A is given by this. So this is back from our vector topic. We've got A1, A2. So this is OA. Suppose the point A is translated through B. So if we translate A through B, it means we apply the vector to it. So we're applying this B vector. Let's just say it's this one here. And so we get this new point. This is B. And this gives us a new location of A. We've moved our point, and our A coordinate is now, it's now a new coordinate, okay? And we'll leave that for a minute. Now, this coordinate here, because we're given this vector here, we can just add these bits together. Whatever our x value is, we're going to add B1. Whatever B2 is, probably a negative number, like looks like a -2, we would add that to it as well. So we would have, this would be A1 plus B1, and this would be A2 plus B2. Don't know if I drew that well enough. Let's just do that a bit better. So A1 plus B1, and then we've got A2 plus B2. Okay. Now the key thing was through matrix B, and it got us to point A dash. Now, this dash might be new, but it's a way to show a translation, a way to show we had A and then we changed it. So the coordinates of this A dash are given by A plus B1, A1 plus B1, and A2 plus B2, which, so from this, we should have sort of got, well, our translated point is actually equal to our original point plus some matrix or some vector. And so, therefore, in this, we see that A1 plus B1 is A2 plus B2, which means if we have a fixed point, we can just, if we write it as a matrix, we can just add this matrix to it. So, as long as we're translating through this, we can just add those matrices together and we get the same thing. Now, this next one, this next little bit, let's just bold this up a little bit. Okay, we've got here forming a straight line. So this is sort of a bit of a step further. If you remember when we had vectors, this position matrix gives us a fixed point, OA. Now, if I make some matrix that goes off in a straight line, I can multiply this matrix B by any scalar. So I could multiply this one by a half, and I could get this point here. Or I could multiply it by 3 or 2 and get this point here. Okay, so this next bit sort of talks about, well, if I have this matrix, and similar to here, we had to a fixed point, and then we had, if we translate it through a vector or a matrix, we can get a point, a translated point. Now, if this point, this matrix here, has a multiplier in front of it, a scalar multiplier, realistically, there's no reason we can't get every point on this line. So you think about this here, just depending on what I do, as long as I've got this fixed point that gets me onto the line, so away from the origin onto a fixed point, and then as long as I've got that parameter, I can go anywhere I want along that line. And so it gives us these matrix equations that our x coordinate is given by A1 plus lambda, which is our parameter, times B1, and the y coordinate equals A2 plus lambda B2. Now, this is a vector equation, but we can, in year 12, we go to parametric equations where we actually would write this as x equals A1 plus lambda B1, and then y equals A2 plus lambda B2. And that means these two equations, we can treat them separately. So I've labelled this fixed point. This is our direction vector, so that's what it's named. So let's look at an example now. So first one is translate the point -3, 2 through 5, 1. So the idea is, if I look at this Cartesian plane, -3 and 2, I'm looking at this value here, and it's saying, this direction vector is saying go 5 to the right and go 1 up. So it's saying, well, 1, 2, 3, 4, 5, and 1 up. Sweet. So this was my original point. This will be my translated point over here. Okay, and we can already see that it's got a coordinate 2, 1. Okay, so 2, negative 1, sorry. So what we do is we change this from a coordinate, and we want to change it into a position vector. So we just change it to a matrix of -3 is its x coordinate and -2 is its y coordinate. Now we're translating it through 5 and 1, which means we're just going, well, 5 and 1, which means -3 plus 5 gives me 2, -2 plus 1 gives me -1. And that's what we got here. We went from this value here, which was, what was it, -3 and -2, -3, -2. And we got to A here, which was 2 and -1. Now this next bit, example, find a vector equation of a straight line through -3, 2, which is parallel to this. So what it's saying, well, if we've got this fixed point, we want a line that goes through this point, like, it's just got to be parallel to that. So that's what it's saying, find a line that goes through this that has a slope of this. So all we need to do here is we can go, well, this will be x, y equals -3, -2, which is our fixed point, plus lambda is our parameter, and then we've got our 5 and 1. Now, here, what we can do is we can go, well, and I can actually show you how to put these in the calculator. This means that pretty much when lambda equals 0, we get this point here, -3 and 2. Okay, and then our next one, I'm just going to put this here. This is our B vector. The B vector is 5 and 1. So this B here goes 5 across and 1 up. And so that pretty much gives us our line. And that means this using this equation, you can get any point. I should have used a different color. Any point along here. We've now got this new coordinate, and it sort of goes all the way through this way and even out a little bit here as well. So it goes on infinite depending on the lambda value you pick. If you pick lambda equals 0, you get this point. If you pick lambda equals 1, you get this point. If you pick lambda equals 2, you get a point out here. All right, so that's pretty much it for this. There's another, they've just stated a little thing that I've missed. So we need to state what values lambda can take, and we are looking at lambda being all real values. It's not anything else. All right, thanks guys.